As shown in this circuit, we need to find out V1 and V2 voltages of the node. We need to mark the ground node, which is the zero voltage node. Next, we need to mark the current that will be flowing in each branch. We can assume, for example, here I am going to assume this direction current. Here in this branch downwards, this is already given. Here let us assume that it is in this direction. So all the branch currents are assumed. Now we need to write the KCL for each and every node. So KCL, Kirchhoff's current law, at node node 1. So if you look at this node, current from here is incoming, and this is outgoing. So we will have V1 minus 0 divided by 2, since it is incoming, so it is positive. Next, incoming current from the dependent source, so it is current source, its value is already written as 2V2, so we will write plus 2V2 plus, because it is incoming current. The next current is outgoing, so minus of the current value will be higher potential V1 minus lower potential V2 divided by minus J is equal to 0. Now generally, for taking the values in the denominator to numerator, I would recommend multiplying. We can do that here, but generally it is much easier to directly use the calculator and find out the values that are there in the reciprocal. For example, 1 by 2 we know is 0.5, so 0.5 V1 plus 2 V2 minus, now from the denominator minus j, when it goes to the numerator it becomes plus j, so it is j V1, and this minus, when it goes inside the bracket, it becomes plus j V2 is equal to 0, arranging which we can clearly see it is 0.5 minus j V1 plus, for V2 we have 2 plus j V2 is equal to 0. So this is our first equation, and with the help of this equation we will be able to write down the values. Let me again check. So you are having here 0.1. Okay, I made a mistake here. The direction of this is from ground to up, so it is incoming, but it is 0 minus V1, so I would better write it as minus, so that gives me minus, and this also comes out to be minus. Rest is all okay, I guess. So now we will go for KCL at node 2. Now KCL at node 2, this is node 2, so we are having incoming current, outgoing current, again incoming current. So the direction of current here incoming, the direction is incoming, so it is positive, so V1 higher potential minus lower potential V2 divided by minus J plus, sorry, minus V2 divided by 2J, and then incoming current, so plus 2 angle 30 degrees is equal to 0, rearranging which we get, which can be written as a matrix form. So the matrix form would be minus of 0.5 minus j, 2 plus j, and the second row we will have minus j for V1 and 0.5 j for V2, So I have missed V2 here. Okay, so that gives me multiplied with V1 V2 as the values going to be 0 and 2 angle 30 degrees. So from this I can find out V1 by finding out what is delta 1 divided by delta, where we all know delta 1 is basically the determinant of the first column replaced by this column, the first column. So it gets multiplied like this is v1 and this is v2. So this v1 row gets replaced by 0, 2 angle 30, and then 2 plus j and 0.5j divided by delta we all know is basically minus zero point 0.5 minus j 2 plus j 0.5j. If we find the determinant and do the division, we will get the answer. Similarly, v2 is delta 2 by delta, where delta 2 is replacing the second column with the column here. So we are having minus zero point 0.5 minus j, then replaced with 0, 2 angle 30 degrees divided by again delta, which is minus zero point 0.5 minus j, then 2 plus j and 0.5j. Solving this using calculator, we will get the answer as 2.46 angle 130.62 degrees, and here we will get 1.23 angle 167.49 degrees.